In this second problem, it is also a no calculator problem. We are given the graph of f prime. The figure above shows the graph of f prime, the derivative of a twice differentiable function f on the interval from -3 to +4. The graph of f prime has horizontal tangents at x equal -1, horizontal tangent at x equal -1, x equal 1, and x equal 3. So the derivative of f prime is equal to 0 at those places. The areas of the region bounded by the x-axis and the graph of f prime on the intervals from -2 to 1 and 1 to 4 are 9 and 12 respectively. So this area is 9 and this area is 12. First part of this asks to find all x-coordinates at which f has a relative maximum. Give a reason for your answer. Alright, so let's start at the left endpoint where x is equal to -3 and see if we can find all the places where f has a relative maximum. Since we are including the endpoints, we have to think about f prime, or whether or not f is increasing to the right or left of those endpoints. So at x equal -3, or to the right of x equal -3, f prime is positive, which means f is increasing, which means f has a minimum at x equal -3. At x equal -2, f prime changes from positive to negative, which means that f goes from increasing to decreasing, so x equal -2 is definitely one place where f has a local maximum. At x equal 1, f prime goes from negative to 0 to negative again, so f is decreasing, remains constant momentarily at x equal 1 because its derivative, f prime, is 0 there, and then continues to decrease again, and continues decreasing until x is equal to 4, which would mean that x equal to 4 is a local minimum as well, and that's all we have. So our answer is x equal -2, and we have to provide a justification for that. So f prime of x changes from positive to negative at x equal -2, therefore f has a relative maximum at x equal 2. That first part is worth 2 points, one for the answer and one for the justification. Part B asks, on what open intervals contained in the interval from -3 to 4 is the graph of f both concave down and decreasing? So to be concave down, f double prime has to be negative, and for f to be decreasing, f prime has to be negative as well. So f double prime is the slope of f prime. So effectively what we're saying is f prime has to be decreasing and f prime has to be negative for f to be concave down and decreasing. Where does that happen? That happens from -2 to -1 because we're using open intervals, and from 1 to 3. If we jump over here to the scoring rubric, this is also worth 2 points. The graph of f is concave down and decreasing on the intervals -2 to -1, 1 to 3, because f prime is decreasing and negative. Notice they write everything in terms of f prime, which is what they have a graph of. So the first two parts worth 2 points apiece. The third part also worth 2 points. It says, find the x-coordinates of all points of inflection for the graph of f. Give a reason for your answer. Inflection points are where the second derivative of a function changes sign. So for the graph of f, we need f double prime to change sign, changes sign. But we do not have a graph of f double prime. What we have a graph of is f prime. So f double prime changes signs when f prime changes from decreasing to increasing or increasing to decreasing. So that's going to take place at the x values of -1, +1, and +3, because those are the places where f prime changes from increasing or decreasing to increasing or increasing to decreasing. So if we take a look at the scoring on that, it has inflection points at x equal -1 and x equal 3. Also at x equal 1. Why'd they separate them here? Because at -1, at x equal -1 and +3, because f prime changes from decreasing to increasing. At x equal 1, because f prime changes from increasing to decreasing. Again, we need to explain in terms of the information that we're given f prime, not f double prime. So you have to relate f double prime being positive or negative to whether or not f prime is increasing or decreasing. And the last part of this question is worth 3 points because we've got 6 accounted for already. And it says, given that f of 1 is equal to 3, write an expression for f of x that involves an integral. Find f of 4 and f of -2. All right, so let's think about what we have here. We have a graph of f prime, and we need to find an expression for f of x. Well, if we integrate f prime, we're going to have, let's say from a to b, f prime of t dt, we're going to have f of b minus f of a. Well, if we were to replace the upper limit with x, f prime of t dt, and the lower limit with 1, we would have the following. We would have f of x minus f of 3. And we were told, I'm sorry, f of 1, and we were told that f of 1 is equal to 3. So if we solve this for f of x, we get f of x is equal to the integral from 1 to x of f prime of t dt plus f of 1, but f of 1 is equal to 3. So if we want to evaluate and find f of 4, we're going to integrate from 1 to 4 f prime of t dt. So f of 4 is going to be the integral from 1 to 4 of the graph above, and the integral from 1 to 4 is not positive 12, it's negative 12 because the area is below the x-axis. So our answer is going to be negative 12 plus 3 or negative 9. F of negative 2 is going to be the integral from 1 to negative 2 of f prime of t dt plus 3. Be careful, from 1 to negative 2 would be an integral of, well, the area is below the x-axis, but which would make that negative, but we're integrating backward, so we have to change the sign on that. So that integral would actually be 9, and 9 plus 3 is equal to 15. So you're going to get 3 points for that. One of them is going to be for this right here, one of them is going to be for that right there, and one of them is going to be for that right there. And I just realized a good example of why you may not want to simplify something. This is a stupid mistake that I made. 9 plus 3 is not 15. It is actually equal to 12.